Okay, so we've made our graph and it looks great. Now we have to read this graph and draw some conclusions as to whether or not the data set supports the original hypothesis. We arrive at the end. Or is it? After you perform an experiment and collect your data, you need to analyze and interpret it. This is where graphs, tables, and charts can be very useful. This will help determine if there is, in fact, a relationship between the independent and dependent variables. In my case, I need to see if there is, in fact, a relationship between coffee consumption and concentration ability. Okay, from the results of my experiment, it's safe to say that for the most part, everyone performed relatively the same on their first reading quiz without coffee here in red. But look at the purple bars over here. It goes up with the numbers of coffee, but then it decreases with cups 3 and 4. So, now I have to interpret these results. I have to explain this data. Now I can offer my interpretation. It appears here that caffeine does cause an increase in concentration, but too much, maybe more than 2 cups, has the opposite effect. It decreases performance. So, what are my conclusions? Do they support any of my 3 hypotheses? Not really. It appears that all 3 are incorrect. But wait, I did all of this work for nothing? Okay, this is one of the most important things you will learn from this experiment. The information you collected is still extremely useful, even though it's not supported. I have discovered new knowledge from this experiment, and it will allow me to create an even better experiment with a better hypothesis in the future. What is it about the amount of caffeine that makes people concentrate more? Why does having so much caffeine appear to make people concentrate less? See how this experiment is opening so many doors and so many possibilities, all while gaining new knowledge about the effects of caffeine. Scientists go through many cycles of testing and analysis before they arrive at a hypothesis that is supported. They even send their data out to other scientists so that they can check for inaccuracies, mistakes in their experimental design maybe, and have them also to recreate or duplicate the experiment on their own. This is called peer review. In our class, you will do something similar in which you, at times, will showcase your results to your classmates in sort of a round-robin fashion where they will offer you or your group constructive feedback on your methods, your hypotheses, your procedures, graphs, and conclusions so that you can tweak and alter your investigations so that it can be the best it can be. You will find that this can be very interesting, very helpful, and a lot of fun. So does a scientific investigation ever stop? Is there a point at which scientists are like, okay, I've sent it out to a dozen other experts and they're all saying that my results support my hypothesis and it's also working with their own versions of the experiment that I made? Well, technically no. Science never stops. It's the speech that never ends, the dinner guest who never leaves. Science teachers' videos who never end. If a hypothesis survives the rigor of peer review, it becomes accepted in the scientific community. This is how we arrive at a scientific theory. In science, a theory is an explanation of some natural phenomena supported by many different experiments that all point to the same conclusion. For example, there is a germ theory of disease which basically says that microorganisms called pathogens are responsible for so many infections such as strep throat. It's not just some hunch or educated guess, it's a statement backed up by tons of research, all pointing at that same conclusion. And perhaps the coolest thing about scientific theories is that they themselves can be improved on, modified, or thrown out altogether. If this happens, then the facts you know in science textbooks can be altered, tweaked, or even thrown out altogether. Newton's laws of universal gravitation, they were improved on by Einstein's general theory of relativity. Pluto is a planet? Yeah, no it's not. We accept it as fact until evidence tells us otherwise. Unlike history or my hair, science can change. All right, we've reached the end of our unit. Please reference these videos on the scientific method and scientific investigations throughout the course of the school year, as they will help you organize and complete your own investigations both at home and in class. See you next time.